Okay, so I'm just going to pick some parts from the starter here just to give us a recap. So over here, we said this would become 2x squared. We increase the power from 1 to a 2, and then we divide it by 2. So x squared. Numbers, effectively, you can just put the numbers as coefficients in front of x. Then don't forget as well the plus c. Let's pick another one here. So this will be 7x minus x cubed over 3 plus c. This one is being integrated with respect to p. So that means you have to integrate the p's. So you would get 3p squared over 2 minus p plus c. What else do we have? Dividing through. So this would become, when you divide through, you would get t squared plus 2. Then when you integrate that, you will get t cubed over 3 plus 2t. Why? Because you're integrating with respect to t. Plus c. Okay, so that's what we did last lesson. So we're starting to understand now a little bit the notation. So if we differentiate, this is what this means. If we differentiate the x's in this expression, then we get that thing there. Well, we can sort of express the same idea backwards with integration notation. So if we integrate this thing here and we integrate the x's, then we get this thing over here. Okay, so what would this mean? If I integrate this thing, what would I want to integrate? I would want to integrate the p's. The p's have taken the places of the x's, this tends to imply. So I would write something like this. Okay, so this is integration notation. Now, a couple more worked examples here. So we often, write it like this. So we put the part that we're integrating in the brackets to avoid confusion. Mostly, you want to know that the whole thing is being integrated with respect to x. So that's why you might write it like this. And we discussed this one here in a previous video. So this would become minus a half first of all, and you would divide by minus a half, which is the same as multiplying by minus 2. So we get minus 2x to the minus half. And then this bit here will become 2x plus c. Okay, we've talked about how to handle different letters here. So what's this going to be? This is going to be 6t cubed over 3 minus t plus c. Simplify that part there, 2t cubed minus t plus c. Now, you need to be a little bit mindful of the letters sometimes in situations such as this. So here, we're integrating the x's. So what are the p's and the q's? Well, they're just constants. So you need to just treat them like numbers. So imagine p was the number 4 and q was the number 5. What would you do with them? Well, you'd kind of just leave them there. And if there were any numbers, you would multiply the numbers by them. So this would become px to the 4 over 4 plus qx plus c. And then perhaps you may write this as like p over 4. X to the 4 plus qx plus c. Okay, so whatever that number is there, we divide it by 4. We can just leave it like that. Have a quick go at the question on the board. So pause the video and just bear in mind what the hint says there to make sure you answer correctly. Okay, so I'm assuming you've done that now. So you should have converted this to x to the minus a half, this part here. Once you've done this line here, as per usual, don't forget the plus c as well. This notation here, this just says you're integrating y. Well, what is y? It's all of this. You're integrating this with respect to x. If you just put a y there, though, it's easier instead of writing that whole expression out. Okay, so we've looked so far at writing plus c because we don't know how shifted up or shifted down the thing that we integrate is. But we can get past that. So imagine I wanted to integrate the gradient function 3x squared. Well, it could be x cubed, it could be x cubed minus 1. In general, we call it x cubed plus c when we don't know c. But if we knew that point there, we could eliminate these other possibilities. We could actually find what the c is. So if we integrate and we have a coordinate on f of x, then there's no need for it to be about plus c anymore. So for example, the gradient function is 3x squared, like we just said. The curve f of x, so curve f of x, how do you find that? Well, you'll need to integrate. Okay, you need to integrate that thing. So if we integrate 3x squared, that line will go through 1, 3. So what do we do? Well, we integrate and then we substitute in. Okay, f of x, remember, is just like your y, your output. So your output would be 3. So in other words, that becomes 3. And then your x, what does your x become? Your x becomes a 1. And then you can find out what the c is. And when you write the c, you write what the line should actually be. Okay, so there's no element of mystery after that. It's x cubed plus 2. So pause the video first on your own to have a go, and then we will talk through this example. So this is f dash x. They are asking you about f of x. So in other words, you need to integrate, and there's a coordinate over here. So in case you cannot read this because it is a bit small, it says 3/8 x squared minus 10x to the power of minus 1 over 2 plus 1. Okay, so I'm assuming that you've had a go at that one there now. So everything was in index form already, so we just said that we're going to integrate everything. What do we get? Well, increase the power is x cubed, divide by 3. That's sort of unsimplified. They've put here divide by a half. That's quite a complicated way of doing it. So it's probably better to say multiplied by 2 plus x plus c. So what would you get if you did that? So you should get an 1/8 x cubed minus 20x to the half plus x plus c. Yeah, that's what you probably worked out. If we substitute in x equals 4 and y equals 25, so you could write f of x equals, or you could put y equals in the situation. So put 25 in here, and all these three here need to be 4, and you will get your c. And your c should be positive 53 by the look of it. If you had to go at the extension question, you needed to find the gradient because it was a tangent. You can find the gradient by using your gradient function, which is given to you already. If you put the x coordinate in, it gives you minus a half. And then this is just your y1 and your x1. It's the same coordinate as from before. So giving you an extra coordinate later on in the question is quite common because it can make the question about integration, but also about straight lines too. And that takes us up to 13c. So you should now be comfortable with integrating more basic expressions in x, sort of x squared and then x and so on, stuff like that. And also using a coordinate to find the value of c.